Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. So in this video lecture, we'll learn about pointer arithmetic in C along with function pointers. So in the previous video lecture, we have discussed about what is a pointer. So let us revise once again and then we'll discuss the topics, that is pointer arithmetic. So pointer is a special variable. So pointer is a special variable which stores the address of another variable. So we can say that pointer is a special variable which stores the address of another variable. So pointer, we have also seen how to declare a pointer and how to initialize a pointer. So int, this is how we can declare a pointer. So name of the variable, so this is the pointer name, it is preceded by star symbol or asterisk symbol you can say, followed by semicolon, and this is the initialization. So p is equal to, so in initialization you have to assign the address of, so suppose some other variable a you have, so assign the address of a to p. So this is initialization and this is declaration. So both the two statements you can combine into one statement, int star p is equal to ampersand of a. So here p is pointing, p is a pointer variable. So we can say that p is a pointer variable when the variable name is preceded by star symbol. So p is a pointer variable, so it will have its own address and it stores the address of another variable to which it is pointing to. Here in this case, it is pointing to a, the variable a. So a will have some value. Suppose a is equal to 5. So this value will be 5 and this will store, p will store, p is pointing to something means here p is pointing to an integer value. So pointing to means it will store the address of this integer variable. So it will have its own memory location, so that we are not writing here. So consider, so this is about pointer declaration and initialization. We have discussed it in the previous video lecture. You can go through the previous video lecture, that is pointers in C, to know more in detail about pointers. Now in this we will discuss about pointer arithmetic. So we can also perform arithmetic operations with pointers, that is addition, subtraction, increment, decrement, etc. So all these operations we will consider one by one with the help of programs. So consider this a simple program here. So where we have declared an array and initialized the array with 3 elements. The size of the array is 3 here. So we know what is an array. Array is nothing but, it is collection of homogeneous elements belonging to the same data type and these are stored in contiguous memory locations. So first element, so array size is, array name is a here. All the elements of the array, they belong to integer type. So size of the array is 3, that means maximum 3 elements. We can store 3 elements in the array. First element is 10, second element is 20 and third element is 30. So each element in the array we can access by using the index. So first element 10, 20 and 30, the array name is given as a. So we can access the first element with respect to its index. First element index is 0, second element index is 1 and third element index is 2. So in order to access this element, so we can write a of 0, then correspondingly we'll get the value 10. So these 10, 20 and 30, these array elements, they are stored in contiguous memory locations. Suppose the address of this is 1000. So next will be, so since it is an integer type, so this is the base address of the first element. So correspondingly, next element will be stored at the address 1004. So we have also seen how to calculate the address of this next element. So formula for that is, so this is the formula, base address plus index into size of integer. So here we are using an integer array. Data elements, they belong to the type integer. So therefore, size of int you have to calculate. So size of integer, so that depends upon the computer architecture. Suppose the size of integer variable is 4 here. So base address is 1000. So 1000 plus base address plus index into size of int. So index is first, its index is 1 into this one. So size of integer is 4 bytes. So 4 into 1, 4. 4 plus 1000 is 1004. So this will be the address of this element, A of 1. So next element will be at 1008. So in this way, you can compute the address of each element in an array. So this is a variable which we have declared, integer variable I, in order to loop through the array elements. So we have used a for loop. So in order to access what we are doing here is with the help of for loop. So in order to print the address of each element of the array, so we are using for loop here. So there are 3 elements. So therefore we need to iterate over these 3 elements in order to print the address of each element. So address of the element can be printed by element is given by A of 0. First element is A of 0. Its corresponding address will be ampersand A of 0. Second element address will be A of 1. Third element address will be A of 2. So we can write all these statements in a for loop, and then I value will be iterating from 0 to 2. So that is what the for loop given here. So initial value I is equal to 0 and I is less than 3. So 3 is the size of this array. So it will iterate from 0 to 2. So I plus plus. So it will print the corresponding address of each element in the array. So this is the output of this printf statement. So A of ampersand A of 0 is equal to 2293296. So we are, in order to print the address, we have used the format specifier %u. So it stands for unsigned integer. So A of I here means I is equal to 0, ampersand A of 0. So first element address is given by 2293296. Next one, the second element address is 2293300. So we can calculate the address of each element by using this formula. So you can you can calculate with the help of base address, you can calculate the address of other elements also. So this is the address of the third element, 2293304. Now if you are trying to print, you can also print the base address of this array by using the variable name array name. So array name here is given as A. So array name is nothing but it is a pointer to the first element of the array. So that means it stores the address of the first element of the array. So if you are printing now A value, so you will get the base address. That is the base address. First element address will be same as this value A, because A is a variable name. A is a array name. It stores the base address of the array. Now let us understand. So this is what, same program you can visualize it. So 3 elements are there in the array, 10, 20 and 30. So this is how we can represent it in the memory. So first element is 20, its corresponding index will be 0. Second element is 1, its index is 1. Second element is 20, third element is 30, its index is 2. So these are the addresses which we have printed by using ampersand A of 0 and ampersand A of 1, ampersand A of 2. So we can calculate we can calculate the address of the each element by using this formula. Base address plus index into size of int. So here this size of integer, this will give the size of integer type data. So here it is 4, so therefore multiply it by 4. So 1 into 4, that gives the address of the second element. 2 into 4 gives the address of the third element. In this way, depending upon the array size, you can compute the address of all the elements in the array. Next is, let us understand it with the help of pointers now. Now what we are doing here, so we have taken the same example here. So array A is declared, name of the array is 3. There are 3 elements in the array, 10, 20 and 30. And what we are doing here is, we are declaring a pointer to the variable A. Pointer to, since A is storing the address of since A is storing the address of the first element of the array, so that address is assigned to pointer variable. So we have seen how to initialize a pointer. So star ptr, so its data type is integer. since all the elements which are there in this array, they are integer type, so therefore it will point to integer type values. So this is equal to A. So here no need to write ampersand A. So another way in which you can initialize it, if you want to initialize it with the first element of with the address of first element of the array, this is other way in which you can do A of 0. So both of them, they refer to the same. So both of them, their meaning is same. So next, this is a for loop to print the address of all the elements of the array by using ampersand A of I. Then base address of the array is printed by using the variable name A. Now PTR is a pointer. So we have created an array. So there are 3 elements in the array, 10, 20 and 30. So each element will have its own address. So that address is printed by using ampersand A of I. So another way in which you can print the address is by using the pointers. Now here we have declared a pointer PTR. So star PTR indicates that this is a pointer variable. So this is storing now this is pointing to the first element of the array. That means if this address is 1000, here the value, its pointer will point to this element. So its address, it will store the address of first element of the array. Now if you print this PTR value, so you will get this value and this value are same. So this is the output corresponding to this is the output corresponding to addresses of all the elements of the array, and this is the base address of the array printed by using the array name, and this is the base address of the array which is printed by using the PTR value, by using PTR. So PTR, and this is by using the array name. So you can see here that both of them, they are same. Both the addresses are same since PTR is pointing to first element of the array. First element of the array. So it will store the address of first element of this array. So for loop, now if you want to print the address of second element of the array, just what you have to do is you have to increment this PTR value by 1. So PTR 1 plus 1 means it will point to the next value. So this is PTR. So when PTR plus 1, so when you do PTR plus 1, so that means it will point to the next element of the array. Now it will store this address. Suppose this address is 2000. So if the array elements are stored in contiguous memory locations, so if this is 1000, this will be 1004, this will be 1008. So now this PTR plus 1 will point to the second element of the array. So plus 1 indicates here that it will point to the second element, next element of the array. So if this is an integer type, this is a pointer which points to integer data type, integer value. So therefore memory will be incremented by, so it will be incremented by 4. So here now it will hold the address of this, so 1004. Now again if you do here PTR plus 1, so PTR plus 2 means, so now it will point to the next element of the array. It will have, so it will store the address 1008. Now it is pointing to the third element of the array. So in this way, you can, with the help of, by adding an integer to this PTR variable, we can access all the elements of the, we can access the elements of the array, as well as we can print the addresses of all the elements of the array. So here in this we are printing the address of all the elements of the array by using the PTR variable, that is a pointer variable. So PTR plus 0 means the first element of the array. So that is 1000. PTR plus 1, so that is the second element address. So that is 229330. So you can compare this value and this value, both are same. So first base address is 2293296. So this address will change as you execute. So this will depend upon the machine. So next element address is 2293300. So this is PTR. So this is ampersand A of 1. So ampersand A of 1 and PTR plus 1. Both are same. So this value is also 2293300. Next ampersand A of 2 value is 2293304. So PTR plus 2. So adding to the base address, we are adding plus 2. So that is equal to, its address is also same, 2293304. So thus in this way we can say that, So if you are incrementing the pointer variable by 1, so it will refer to the memory location where the second element of the array is placed. So each element of the array will store the base address. So it will this PTR will hold the base address of each element of the array. So in this way you can understand. So we have used for loop here, and which is used to print the address of the array elements with the help of the variable PTR, pointer variable. Next, one more example we will see here for pointer arithmetic. So here also we have taken the same array. So there are 3 elements in the array, 10, 20 and 30. So 10, 20 and 30. So PTR. So now we have declared a pointer variable. So integer pointer. So it will point to an integer variable or integer value it will point to. So this is holding the address of a of 2. So a of 2 this is a of 0, a of 1 and a of 2. Now this pointer variable is pointing to this element. So it will store the address of this element. Suppose its address is 1008. So its address also will be 1008. So its value will be 1008. Sorry, PTR value will be 1008. So this is pointing to a of 2 here. So we are using for loop here in order to print the address of all the elements of the array. So according to the program, the address of the first element of the array is 2293. So first element address is given by, or we can visualize it in this way. So this is 2293296. This is 2293300. 2293304. So PTR will hold the address corresponding to this one, that is 2293304. So last element. So now if you perform, PTR address is PTR. Now if you print the address of PTR value, it will show the address of this last element of the array. So now what we are doing here is decrement PTR minus minus. So PTR minus minus is equal to, so PTR minus minus it is equal to PTR minus 1. So this statement implies that PTR is equal to PTR minus 1. So this is what it means. PTR minus minus means PTR is equal to PTR minus 1. So this means that it will move to the memory location where the second element is placed. Now here PTR is pointing to the last element of the array. So here 1, 2, 3 elements are there. That means it is pointing to the third element of the array. Now if you do this, PTR is equal to PTR minus 1, then it will point to the second element of the array. Now it will store the address of second element of the array. So this is what it means, 2293300. So if you print the address, if you print the value of PTR, you can see that, so it is same as 2293300. So in this way, we can perform pointer. This is pointer subtraction. So when you perform pointer subtraction, so with the help of, so this is pre-increment and this one is pre-decrement and this one is post-decrement. Next, one more example we'll see for pointer arithmetic. So here also we have taken the same array A. So A is an array. It is having 3 elements, 10, 20 and 30. PTR is storing the address of first element of the array. That means PTR is pointing to this one. Suppose this is 1000. So it will also have 1000. So PTR is storing the address of the first element of the array. Now if you try to print the value of, so with the help of this star operator means, so dereferencing the value at this address. So dereferencing the value at this address means, so we can interpret it in this way, star PTR plus plus. So here the value of the data pointed to by PTR will be extracted first. Then the pointer will be incremented. So that means the value of the data pointed to by PTR will be extracted first. So that means first 10. So this is post increment operator. So this is post increment operator which is applied to PTR. So first the value will be accessed and then after that PTR will be incremented. That means after that the PTR will be pointed to the next element of the array. So first, what is the value here? Corresponding value is 10. So that is given. Then after that PTR will point to the second element of the array. So this operation you can interpret in this way. First, this will be evaluated star PTR. So PTR is pointing to the first element of the array. So its value is equal to 10. Its value is equal to 10. So that is printed. After that, so this is the output of this one. So after that, PTR is incremented by 1. So that means it will point to the next element of the array here. So if this next element address is this, so this will be the address, this will be the value of PTR now. Now if you are trying to print the value at this PTR, now it is pointing to the second element of the array. So yeah, at this address, so value is 20. So 20 will be printed. So in this way, we can evaluate this statement. So next is one more example of pointer arithmetic. So here we have applied pre-increment. We are using pre-increment operator. So suppose here also we have taken the array 3, 10, 20 and 30. So star PTR is equal to A of 0. So PTR is storing the address of the first element of the array. So PTR, suppose this is 1000. So this will point to the first element of the array. Its address will be stored in the PTR variable. So next, after this, when you are trying to print the value at this value in this PTR value, so this will be evaluated in this way. First, in this statement, we are using pre-increment operator. First, PTR will be incremented by 1 plus PTR implies that PTR is equal to PTR plus 1. So that means now it will point to the next element. Now it is pointing to the next element. So memory will be increased by 4 bytes. So if the initials, if PTR value is 4000, so with this next it will be PTR plus 1 will be, this is equal to 1004. If this is PTR, so PTR plus 1 will be 1004 if it is an integer pointer. So since it is an integer pointer, so therefore PTR plus 1 will implies 1004. So it will point to this memory location. Now at this particular memory location, first PTR will be incremented by 1. So it will point to the next element. So corresponding value will be stored here. So 1004, now it will store 1004. And then at this location, now we are dereferencing the value at this address. So value at this address is 20. So 20 is the output. So this is how we can evaluate this statement. So next one, this is pre-decrement and this one is post-decrement. So pre-decrement operator, how it is evaluated is, so here we have used an array. Array elements are 10, 20 and 30. So let the address be 1000, 1004 and then 1008. So PTR is pointing to A of 2. PTR is storing the address of the last element of the array. So that is PTR value will be 1008. Now it is pointing to this last element of the array. A of 2 means the index is 2. First elements, the index is here is 0, 1 and 2. So it is pointing to the last element of the array. Now if you do this, if you evaluate this statement, then this is the output. So star, first pre-decrement will be performed. This is pre-decrement. So PTR is minus PTR implies PTR is equal to PTR minus 1. So PTR minus 1 means it will move to the previous element. So now it will point to the previous element. So previous element is this one. So it will store this value. It will store the address of this element. Then after that, the value is accessed. So at this particular location, the value is 20. So corresponding value 20 is the output here. Now if you perform this one, so first, so this you can interpret as in this way, star, this is post decrement. So this is pre-decrement and this one is post-decrement. So this you can interpret as in this way. First, star PTR will be evaluated. So value at that will be evaluated first. After that, PTR will be decremented by 1. So PTR is equal to PTR minus 1. So the output of this is 20. So why? Because the value at this particular, previously it was pointing to the second element of the array. So 20. So same output you will get here. So 20. First, this will be evaluated star PTR. So value at this particular address will be obtained. So 20 is the output here. After that, its PTR value will be decremented by 1. Now it will store the address of the first element of the array. So now it will store the address of the first element of the array. So if you're trying to print the value at this address, so value at this address is 10. So that is the output of the third line. So in this way, we can perform pointer arithmetic. Now let us evaluate these statements. So if we are writing that z is equal to, so we'll understand it with the help of programs. So if you are writing z is equal to star plus plus p. So here p means pointer variable. So p is a pointer variable pointing to an integer type and z is an integer variable. So this is equivalent to, so this statement is equal to, so z is equal to star plus plus p. So this is pre-increment. So when you are performing pre-increment, first the pointer value will be incremented by 1. So p plus 1. If p has value 1000, so next p plus 1 will be obtained. P plus 1 means 1004 will be obtained. So after that value will be this value, whatever value is there at this particular address, so that is assigned to the variable z. So this increments the pointer p to point to the next memory location where the next element is stored and then assign the value at that location to z. So next, consider this statement. So z is equal to plus plus. So here also we have used pre-increment. So but in a different way, z is equal to plus plus star p. So first what is done here is first pre-increment this expression. So this is how the statement will be evaluated. So star p is equal to star p plus 1 is equal to star p plus 1. That means the value at this particular address is incremented by 1. So here not the pointer is incremented by 1, but the value at this address is incremented by 1 and that is assigned to the same, that is replaced by the same variable. So star p, and then after that, that particular value, incremented value is assigned to z. So for this we'll see an example. So this expression first modifies the value pointed to by p and then assign that modified value to z. So first it will modify the value pointed to by p. So first, and then it will assign that modified value to z. So for this corresponding example we can see here, we have declared an array here. So there are 5 elements of the array, 10, 20, 30 and 40 here. So 10, 20, 30, 40, 50. So these are the 5 elements of the array. So array name is numbers. So first element, so we have declared an integer pointer here. So which points to the first element of the array. So star p, so p stores the address of the first element of the array. Suppose this is 1000, so this will also be 1000. So we have declared an integer variable z. So now we are performing this with this statement. What is done here is, so z is equal to star plus plus p. So with this, first this will be evaluated. P value is incremented by 1, p is equal to p plus 1. So p plus 1 means now it will point to the next element. So next element address is 1004. This is 1004. So after that, z is equal to star p. So this value, whatever value p is pointing to, that is assigned to z. So now z is equal to 20. So if you print the value of z now, so you will get the value 20. So in this way, you can understand this. So star plus plus p means first p is incremented by 1, pointer is incremented by 1, and then whatever the value pointer is pointing to, so that is assigned to the variable z. So next, one more example for pointer arithmetic. So this statement, we'll understand the use of this statement. So plus plus star p. So here this means that star p is equal to star p plus 1. So after that, z is equal to star p value is assigned to z. So we can understand it in this way. So there is an integer array 10, 20, 30, 40 and 50. So these are the 5 elements. So P is pointing to numbers. That means P stores the address of starting element of the array here. So this is 1000. This is the value of pointer P. So we are performing this. So with this statement, let us see what is the output. So star P is equal to star P plus 1. So P is pointing to the first element of the array. So star P means value at this address. So value at this address is 10. So star with this statement, star p is equal to 10 plus 1, that is 11. Now this 11 value is assigned to z. Now z is equal to 11. Now if you are trying to print the value of z, so you will get the value of z as 11. So value at the first element, correspondingly at this particular 10 value is also incremented by 1. So that is equal to 11. Next, pointer arithmetic. So this is post increment, and this is also post increment, but we are using it in a different way. So this is equal to, so first this value will be dereferenced, value at this point, value at this address will be dereferenced, and that value is assigned to z variable. Then after that, pointer value will be incremented by 1. That means it will point to the next element of the array. Next, this statement is equal to, so value at this address is assigned to the variable z, and then after that value will be incremented by 1. So value at this address is assigned to z first. After that, that value will be incremented by 1. So we'll see an example. So more examples on pointer arithmetic. So here we have used an array. So we have declared and initialized an array. The array size is 3. So there are 3 elements of the array. These are the 3 elements 10, 20 and 30. So we are declaring 2 pointers here. First integer pointers. So pointer ptr and other pointer variable is qtr. So ptr is pointing to the third element of the array. So this is the third element. So a of 0, a of 1, a of 2. Ptr is pointing to the third element of the array. So whatever the address of this a of 2 is, so that will be stored in the variable ptr. So qtr, we have declared another pointer variable qtr. So it is storing the address of second element of the array. So this is qtr. It stores the address of second element of the array. That means it is pointing to the second element of the array. So if we write this statement, so we can also use relational operators here. So if we write ptr is less than or equal to qtr. So naturally, if this address is 1000, this address will be 1004, this will be 1008. So if with this statement, ptr is less than or equal to qtr. So ptr address is 1000. It is less than or equal to 1004. This is false. So this statement is false. So output of this will be 0. So that is the output here. Now if we write this, if we apply greater than or equal to relational operator, ptr is greater than or equal to qtr. So ptr is 1008. This is greater than 1004. So output of this will be 1. So that is the output here. Now if you're writing this statement, so with this statement, now qtr is pointing to the last element of the array. So qtr is also pointing to the last element of the array. So with this statement, so if you use relational operators, equality operator here, ptr is equal to qtr. So both are pointing to the both are pointing to the same value. So therefore, or both are holding the same addresses. So therefore, both are equal. So output of this will be 1. So in this way, we can evaluate the output of these statements. Now consider one more example. So here we have declared an array A of 3 is equal to 10, 20 and 30. There are 3 elements in the array. So star PTR is equal to ampersand A of 0. So that means it is pointing to the first element of the array. PTR is pointing to first element of the array. Then QTR is pointing to the last element of the array. Suppose now if you write this QTR minus PTR. So this operation, so we can subtract two pointer variables if they are used with respect to the same array. So if they are used with different arrays, we cannot write this statement. So with this statement QTR minus PTR. QTR is pointing to the last element of the array. So it will have some address. Suppose the address is 2293304. So this value minus PTR. So PTR is pointing to the first element of the array. Its address, suppose it is 2293296. So if you subtract these two, you will get the output of this statement is, so the output of this program is 2. So how you are getting 2 here is, so you can see here QTR minus PTR is equal to 2293304 minus 2293296. So here it is equal to 8. Difference of 8 bytes you have. So 8 divided by 4. So this 4 is nothing but, so it depends upon the type of the pointer. So here we have used integer pointer. So type of the value to which this pointer is pointing to. So here we have used integer values here. So size of integer value is 4. So therefore 4. So difference of these two addresses divided by 4 divided by the size of integer. So that is equal to 2. So that's why we get the output as 2. So function pointers. So this is another concept of pointers here, function pointers. So same as we declare a pointer for a variable, we can store the address of other variable. So we can also store the address of functions also. So we'll see the syntax, how to declare a function pointer, how to initialize a function pointer, and how to use function pointers in programs. So as we declare a pointer to a variable, this is equal to ampersand A, where A is an integer variable. So similarly, so A is an integer variable and this is a pointer which is pointing to an integer value. Similarly, we can use this for function pointers also. Pointers to functions enable you to save function's memory location in a variable and subsequently call the function using that variable. So we can store the address of the function also in the pointers. So for syntax for that is, so we can declare a function pointer in this way. So in any function, suppose we write the function as int, return type of the function is integer, and add is the name of the function, and it is taking two arguments, integer a and integer b. So this is a function definition, and here function statements are a plus b. So this is what it is doing, this function is doing. So function declaration, function pointer you need to declare for this function first. So return type is integer here. So this will be int. First you need to specify the return type, after that star and then followed by the pointer name, and in brackets you need to specify the data type of the arguments or parameters, followed by semicolon, and then assignment. So since we are using a pointer to a function, we need to store the address of the function in the pointer. So in this way you can write it, ptr pointer name, then after that followed by assignment operator, followed by the name of the function. Then how you can invoke the function? So in order to use the function, so we need to call the function. So in order to invoke the function, once the function has been assigned to function pointer, it may be called by using the function call operator or dereference operator. So we can call the function by using this or this one. These are the two ways in which we can call the function. star name of the PTR name. Here these brackets are important. Here also you need to specify the brackets. So star PTR name and then followed by the arguments. Whatever arguments you are passing or parameters which you need to pass. So those are here arguments, or PTR name followed by arguments. So this is an example of function pointers. So this is a function definition. So here we have used two functions here. First function name is add. The other function name is subtract. So the task of this function is to add two numbers and return that value to the calling function. The task of this function is to subtract two numbers and return the subtracted value to the calling function. So here in the int main function, so this is function declaration, function pointer declaration. So we are declaring the function pointer in this way. So return type of this function is integer. So therefore we are writing integer here also. Then after that in brackets we need to specify the name of the pointer. So name of the pointer here is star PTR and then followed by the arguments or parameters. So here it accepts two integer parameters. So therefore we are writing int and int. Then this is function assignment, function pointer assignment. So assignment, so you need to assign here. So name of the function, so name of the function is add here. So that add name is assigned to the pointer variable. Then after that this is function calling or invoke the function. So in this way you can call the function. So name of the pointer and then inside this you have to pass the parameters. So here it accepts two integer parameters. So 15 and 30, these are the parameters which are passed in the function. So addition of this value, the output of this is an integer, the return value of this function is an integer value. So that value which is obtained from this function, so that is stored in the variable result. So output of this will be, so suppose if you pass the 15 and 30, so output of this will be 45. Now what we are doing here, so same function so here we have used another function. The return type of this is an integer. Name of the function is subtract and here also we are passing two integer parameters here. So we can assign this function name to a pointer, same pointer you can see. So subtract is equal to, so name of the function is subtract or address of this is assigned to the pointer variable PTR. So you can also write PTR is equal to address of the subtract. So both are correct. PTR is equal to name of the function also refers to address of the function. So subtract is equal to PTR. So this is also right. After that function calling. So we can call the function by using the name of the pointer variable. Name of the pointer variable here is PTR and inside this pass the parameters to the function. So 15 and 20 if you are passing. So control is transferred here. So when control is transferred here, so this statement will be executed. 15 minus 30 is 40 minus 15. 15 minus 30 is minus 15. So this value is returned to here and that value is stored in the variable result. So if you are printing the value of result now, you will get minus 15. So in this way, you can store, you can not only store the address of other variable, but also you can store the address of functions also. So in memory function, suppose we are declaring a function add, so it takes some arguments. So it has some address. So the base address of, suppose this is 1000. So base address of this will be allocated to this pointer variable. So that is what we are doing here. We are assigning the address of this function to the pointer variable PTR and then we are calling the function with the pointer name. So in this way we can understand the example of function pointers. One more example. So this is a function prototype, void high function. It takes integer arguments. Return type is, it does not return anything. So therefore void we have used. So this is a function pointer declaration. So we are declaring a pointer to a function. So return type is void. This is the pointer variable, pointer to a function, and then inside this parameters. Parameters are, it is accepting only integer value, so int. So name of this function, so name of the function is high here. or in the function definition, you can see name of the function is high function. So this address of this is assigned to the function ptr. So this is pointer assignment. We are assigning the name of the function to the function pointer, and then we are calling the function here. So here we are passing the value 3. So this value is received by this variable times. So 3 times is equal to 3. So here inside this we have defined variable k is equal to 0. So it is iterating 3 times. So it will iterate for 3 times. So the loop will iterate for the number of times depending upon the argument or the value which we are passing. So it will iterate 3 times here. So 0, 1, 2. So it will print high 3 times. So it does not return anything to the calling function. Just it is taking arguments from the calling function. So arguments are passed from the calling to the called function. So it will print high 3 times. So in this way, so this is all about function pointers. In the next video lecture, we'll discuss some more concepts of pointers in C. So until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.